Okay, so y'all want me to show you the calculator first, or you want me to actually walk you through this? Calculator first. Okay, to put it in your calculator, you have to get it y prime equals something. So we got to do some algebraic manipulation. We have to get dy dx by itself. Well, that's not all going to be all that easy, is it? No, it's not. Are you sure you want to do calculator first? Not anymore, because the dy dx is not by itself. It's really not that bad, actually. So to be able to put this in the calculator, we'll do this. I'm going to subtract the dx over there, because I know I've got to have the dx in the bottom. So I'm going to have e to the negative x, y squared minus 1, dy equals negative xy dx. I'm going to divide both sides by this. I'm going to get dy equals negative xy e to the x, because the negative means it's in the denominator, so I'm multiplying it. All over y squared minus 1 dx, divide by dx, I've got dy over dx equals negative xy e to the x over y squared minus 1. This is what you have to put in your calculator to do this. Okay. That wasn't that bad. It looks a lot worse than what it really is. So in your calculator, you're going to do your DE solve. You're going to do, okay, here we go. So we need to go ahead and solve this by separating variables, do separation of variables. We need to get all of my x's on one side, all of my y's on the other, so we got to do some algebraic manipulation. I'm going to do the same thing. I'm going to subtract the xy dx. I'm going to have e to the negative x, y squared minus 1 dy equals negative xy dx. I am going to divide by e to the negative x, put it on this side. I'm going to divide by y, put it on this side. So I get y squared minus 1 divided by y dy equals negative x times e to the negative x dx. All right, we're ready to integrate now, right? Oh, yeah, well. Oh, dumbass. Here. Something's not right. Yeah. The idea of putting the calculator is still the same. I forgot to put the square on that. So it's e to the power of x squared. I had to add a square to this. I wrote the problem down wrong. So the answer you had was wrong, but even if you go back in and you just put the square on the e to the power of x, it'll be okay. So now we're going to integrate both sides. Still doesn't look okay, right?
It looks worse.
It looks worse? Okay. Okay, here we go. Has an integral in there. So, how am I going to integrate this? No. Separate it. So we're going to do the integral of y squared over y, which is just y dy, minus the integral of 1 over y dy equals, okay, I'm okay with that. So we just split this into two different terms.
Wait, y dy or y dy?
Oh, this is dy. The whole thing is dy, sorry. The what? Minus, here's my 1. All right, how about over here? What are we going to do? Do a u. U equals x squared. So my du equals 2x dx, therefore my dx equals 1 over 2x du, right? So then this really becomes a negative integral of x e to the u 1 over 2x du. These x's go away, so I can erase them, right? And this 1/2 comes in front, so I can clean this up. This becomes negative 1/2 e to the u du. Well, this seems pretty easy to integrate now, doesn't it? What's the integral for this? 1/2 y squared. Now technically plus c, but we're going to add it to this side. It doesn't matter. Minus, what's the integral of this?
Oh, that's easy. Well, one second, I'm working on it. 1 second. No.
So the negative came out, and then I want to cancel when I put in my du, because I have an x on the bottom. It sounds like the tennis team's like, no. Okay, so what is this? Come on, guys, what is this? This is easy. ln of the absolute value of y.
Too easy. No.
Too easy, I agree. I think his friends are hitting unmute. Equals negative 1/2. What's the integral of e to the u? It's just e to the u plus c. All right, let's back substitute. What is c? What is u? Okay, so now we have 1/2 y squared minus ln of the absolute value of y equals negative 1/2 e to the x squared plus c. Now I need to solve for c. But I already know an x and a y value. Which one's my x? Which one's my y? 0 is the x, therefore 1 is my y, so just plug them in. I've got 1/2 times 1 squared minus ln of the absolute value of 1 minus negative 1/2 e to the 0 squared plus c. Right? Here we go. What is 1 squared? The 1 times 1/2 is? Minus, what is ln of 1? It is 0. Equals, what's e to the 0 power? 1. What is 1 times a negative 1/2? This gives me 1/2 plus 1/2 equals c, therefore c equals 1, right? Therefore, my particular solution, and I'm just going to write it right above this, is going to be 1/2 y squared minus ln of the absolute value of y equals negative 1/2 e to the x squared plus 1. There's my particular solution. So it's really what we did yesterday.
Are we checking?
All right, now, what if I give you something like this? I'm going to just change up the verbiage. Find a particular solution of the curve, so I'm talking about a graph, that passes through a point 1, 3, and has a slope of y equals y divided by x squared at any point xy. Okay, so hold on, I want to write it. So your slope of any point is y over x squared for all xy. The upside down A means for all. And then it gives you a point of 1, 3. So literally it's the exact same question, it's just a different verbiage, right? So you have to recognize slope is your dy dx, right? So you have your dy dx. This just says this basically confirms this derivative. If it just says this is the equation for just one point, then it's not the derivative. This part confirms this is the derivative. And then from here, separation of variables. So we're going to do 1 over y dy equals 1 over, well, let's just do x to the negative 2, it'll be easier. X to the negative 2 dx, we integrate. This becomes ln of the absolute value of y equals, let's see, x to the negative 1 over negative 1 plus c. Ln of the absolute value of y equals negative 1 over x plus c. Both sides. Plug in our values. Right? Here we go. This gives me the absolute value of y equals e to the negative 1 over x e to the c. This gives me basically y equals, there's supposed to be a plus or minus, but it's going to be absorbed by the c, right? So we have c e to the negative 1 over x. Now this is going to be easier to do our particular solution versus trying to do ln of 3 like you were saying, right? So now we're just going to plug it in. My y value, let's just make sure, it's 3, right? I've been screwing up points all week. 3 equals c e to the negative 1 over 1. Which now when I solve for c, I get 3, what is this, e equals c? Is that right?
Yeah.
Yeah, because this is basically 3 equals c over e, multiply both sides by e, and this is what you get. Yeah, this right here is technically 3 equals c over e. Because this is to the negative 1, negative first power, which are exponent rules. Yeah, swapping signs, just when you move to the other side, you swap that negative sign out. Okay, now from here, we plug it back into this, and I've got y equals 3e times e to the negative 1 over x. Well, whenever we're multiplying with the same bases, we're adding the exponents. So we have y equals 3e to the 1 minus, because plus a negative, 1 over x. This is going to give me y equals 3e to the x minus 1 over x. And of course, my x has to be greater than 0 for a couple different reasons. 1, it's in the denominator here. 2, I have ln right here. So this doesn't allow any negative numbers or 0, so that's my most restrictive domain. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.